In this example of a logarithmic equation, we have to combine our understanding of logarithms and their definition as the inverse of an exponential with those rules that we've already identified for manipulating and simplifying logarithms. So because we have the sum of two logarithms here, our product rule for logarithms suggests that we're going to be able to combine these two logarithms, because they share the same base, into one singular logarithm of the product of those two inputs. So instead of having log base 2 of x and log base 2 of x minus 7, we're instead going to have log base 2 of x times x minus 7. It's at this point, because we're down to one logarithm, that we can rewrite this as its exponential equivalent. We know that this is 8. We know that that's x squared minus 7x. I see this squared term, so I'm definitely going to want to set everything equal to 0 by pushing the 8 over to the right. And I get my two solutions via factoring. X equals 8 and x equals -1. We mentioned in a previous video the necessity of checking to make sure your solutions are correct. This is an example of one where we're actually going to lose one of the solutions as we attempt to back substitute it. Let's start with the 8. Log base 2 of 8 plus log base 2 of 8 minus 7, which is 1. Well, this logarithm has a value of 3 because 2 cubed is 8. This logarithm has a value of 0 because 2 to the 0 is 1. That is all 3, so that one checks out. -1, or excuse me, 8 is a good solution. 8 was a good solution. We didn't check the -1 yet. Now let's check the -1. Log base 2 of -1. And we're already done. There's no need to go any farther. There is no power of 2 that will get me a negative number. If you really wanted to keep going, you could write log base 2 of -1 minus 7, which is -8. That's not going to work either. So there's no power that's going to change those signs for us, thinking of these in terms of the exponential. So despite the fact that -1 came out as a solution to this equation, that does not necessitate that it would have worked in the original equation because of that positive relationship we're looking for in those exponential evaluations. So -1 is out, -1 is out, and 8 is the only solution to that equation.